Okay, this is the demonstration for the methods section of uh, our, our paper, meaning Jack Nelson, Conrad Lashim, and me, Caleb Anderson, um, where we did a little bit of investigation into automated honeypot and rug pull scams. Um, so yeah, I'm just gonna go right into a demo of how we would start the research process. So we'd hop on over to Deck Screener. They have this functionality called new pairs. Um, for reference, new pairs is where basically everything is a total scam. If you buy a new pair that came out within the last, 1 hour, there's probably an 80% chance that it's already been rugged, a new pair within 1 hour, and there's data out there that shows that 97 to 99% of these new pairs eventually uh, basically go to zero, whether that's through pulling the liquidity pool or selling a large amount of them. Um, but yeah, so we're gonna go ahead. We did this for Binance Smart Chain, um, and we can rank and filter these. I'm gonna do zero liquidity because this way it'll show us even if it's been totally rugged, which is we're going after rug, so we'd like to see that. I'm gonna rank it by pair age and ascending. So this is gonna show me all of the newest pairs, no matter what liquidity they currently have. And then we can see there's this tab here, volume. Um, Everybody knows what volume is, but we're looking for a pair that has had a lot of trading history and also has no value. So we can see in this token here, there's a few of them, but this one is one that you're going to see very often whenever you do something like this. Is has about $200,000 of volume, and every last dollar of liquidity has been pulled, so it's down 100%, less than $1 of liquidity. Um, so yeah, we'll go ahead and go here, and we can copy. Oh, we need to go to the address on Binance Smart Chain and go to the last, and we can see this deployment transaction here. And it came from this wallet. So this is our wallet that we're gonna be investigating. I basically just showcased how we would find these wallets. And now we're gonna go on to the software or data analysis portion of this. Um, if you want to take a look at the code, it's on GitHub. It's linked in the paper. I'll probably link it on this video as well. Um, yeah, going over to VS Code, I already have my virtual environment set up. Another thing I will say is you need to get a Covalent HQ API key um, in order to use this. But that's pretty easy to do. You just got to make an account. It's free. Um, so yeah, we'll switch this to the new wallet. This is the new person's wallet that we just pulled that deployed that. Um, and we'll just do max depth of 4 um, just to make this a simple process. Um, Go ahead and save the file. And I already have my virtual environment set up for this. I recommend if you're using VS Code, like look up how to set up a virtual environment and install your packages. Okay, I seem to have this working. The Covalent HQ service has seemed to be a little bit touchy for me. Yeah, so we're not going to be able to get it perfect, but this is just for demonstration purposes. We will have some missing data, but we'll just make do with what we got. Um, but yeah, Covalent HQ API has been a little bit touchy for me personally. I'm not really sure exactly why. Um, Maybe I have bugs in my own code, but this is a new one that I haven't really seen, this 503 message, so they probably have something going on. But yeah, I suppose we can go over the code a little bit. Um, But yeah, so we have this main runner file um, here for the algorithm, which is very simple. Just import the object, and then all you have to do is change the wallet address, and it runs the strategy for the amount of depth that you want. So my simplest explanation of depth is we'll say that this address is basically the zero address. It's the starting address. So once we so we're looking at BNB transfers as well. So once we look at all of the BNB transfers into and out of this wallet, basically all of the other wallets and contracts that this um, wallet has interacted with is now depth one. So this is our zero depth wallet. All the wallets and contracts that the zero wallet has interacted with is depth of one, and then all of the depth one wallets have interacted with uh, that would be depth two. It's kind of I think it's easy enough to understand. So we go back to wallet investigator. Um, And yeah, so we just, set up the data. So a lot of this code here um, is simply just so we don't check the same account twice. There might be a simpler way to do this, but I thought this wasn't really that complicated. It's only about a 100-line file. Um, so yeah, when we call run, we're just calling the API, which is down here. Um, and returning the data that the API gives you, um, which there's a lot of data, of course. And then we're just making sure that we're not going past the max depth, and we just, every time that we get the transactions, we just append them to the list to check again, and then we essentially just keep calling these transactions until we have a big data file, which is all the raw data from the API. And then this is our clean data. So basically what we're doing in this function here is we're just taking in all of that raw data, and then we're basically adding all of the transactions together. You can see we're just doing a little bit of math here, converting from Wei to Ether, um, and adding somewhere in here. But yeah, we're basically aggregating all of the transactions that the API gives us into a single directed network or weighted directional graph, um, or a directional weighted graph, something like that. Um, yeah, maybe our code is done. Yeah, so our code is done now. And we have our raw data, which is everything that the API gives us, and then it also cleans it down into this nice CSV file. Um, and yeah, the data right here, I mean, a lot of this can tend to be very obtuse. Like, for example, here we see he's sending 200 something BNB and 90 something BNB. However, this address here is the pancakeswap router address. So this is just this account making a trade. Um, and these guys definitely take go through processes to make what I'm doing here a lot harder, um, by using, for example, multi-sig transactions and things of that nature. Um, we'll go ahead and go over to Gephi and just show how to load this data in. Um, we'll just do a new project. Um, we I need to copy this as a CSV. Um, okay, so now this is in a CSV, and we are going to import spreadsheet. And this would be, okay, that was kind of weird. In my D drive here, uh, so yeah, weight is the double, graph type directed, edge merge strategy. This doesn't really matter because we already did that. Um, the code, the data cleaning does that for us. Uh, New workspace, okay. You can see our nodes and edges, and then we can go to overview, and it should show us a weighted directed graph, which is, you can see. So these larger transactions are the ones that I pointed out um, here. So, oh shit. Here, as you can see, and here as well. Um, yeah, with further investigation, you can turn labels on with the software. I'm not super great with it though. Um, there's also other layouts that you can choose. For example, do if on who. So this is gonna. Um, I don't know exactly what these algorithms are doing, but I know that this one generally uh, kind of makes like separate populations in a way. This was the one that we used for Nanoraka, but yeah. So yeah, if you're looking to do this yourself, definitely play around with these algorithms wherever you get them. You can do like Force Atlas. You know, there's a lot that you can do, and just find the one that kind of, I guess, makes your data more literate, I suppose, makes it easier to read and understand. Um, there's multiple different ways you can do it, including adding labels. Um, and I suppose it's constructive enough to show sort of like a manual analysis of, one of these deployers. So this is the deployer of the scam token that we just did. Um, yeah, we can see he transferred his money here. And this one's a new one. So we can see we go to more recently. Yeah, so he sent all of his money into this new uh, wallet and then created a contract 30 minutes ago. Did some random stuff, uh, basically like renouncing ownership. Is something that makes people trust your token more. And then yeah, he creates the pair as liquidity. And if we were to watch this a little bit longer, so yeah, and he's also transferring his money out to these wallets. So we can go to this one here, um, or we'll go to one that did. Oh, this happened very recently. But if we went to these wallets and waited a little bit, we'd probably start to see them um, interacting with the new token and trading it. You can see it's sending thousands of dollars each time that this is going on. Um, but yeah, kind of showcasing the timing of it. So 30 minutes ago, this contract was made. And then if we go back to this address, we're going to start to notice a specific time interval that this liquidity is being moved around to. So last time it was 30 minutes. This time is an hour and 3 minutes, um, which is Asgard token. And you can also look and see on the new pairs that like there's this guy's token, and then there's really like one guy who's doing like most of the large scams, at least on pancakeswap. Like every half hour or so. There may be some other people who do it a little bit more sparingly. So we saw a 32-minute time gap roughly, and then we can go to where the money came from again. So you can see that this wallet got all of its money from this wallet. And now we go back here and see this contract deployment. So yeah, another roughly 30-minute gap. So you can see that each time uh, this money is getting sent to a new account, and almost exactly 30 minutes in between each of the contract creations, another contract is created. So it keeps on reflushing this money and undergoing this cycle of making these fraudulent pairs over and over again, um, until basically they make money. There's probably they probably have some way of laundering it as well, either through a mixer, but we have yet to narrow down an exact hot wallet interaction with this guy. Uh, I suppose another thing to add is, these guys use the so in order to basically get the whole concept of this is like this crypto is not really worth much to them on the blockchain, because it's very easy to see that the activity behind this specific BNB that's uh, like purposely being moved throughout the blockchain, like you can track this and see that this pile of BNB here is uh, used for scams. It's very easy to see. I'm kind of showing it here. So it's for whoever is owning these accounts, it's this BNB really isn't worth that much to them sitting here because it's so obviously fraudulent. So what they do a lot of times is even when they do interact with the hot wallet, which is like a wallet that you need to be KYC'd for, like if you have a Binance account, you are KYC'd, you need to give up your identity, you need to prove who you are. So what they do in order to circumvent that is they actually uh, do even more frauds a lot of time. A lot of times they're phishing Binance accounts so they can steal somebody's Binance account in order to get, that KYC, or maybe they even fake a KYC. It could even go down to the bank account as well. So if they could have a phished bank account and a phished Binance account, and then everything is just hard to trace unless they figure out how this person stole all of this. So a lot of this is actually a much larger network of scams than it may appear to be at first sight. Okay, and looking at this token contract, so this is a token contract that was deployed by the owner of this pile of BNB that we're talking about here, and this is the EagleBit contract. Don't buy EagleBit. EagleBit is some random token, clearly a scam. None of these tokens should be, this is not a method that you want to do to find tokens to buy. So definitely, uh, and don't be surprised if you haven't heard about it either. All these are just very random scams. Um, yeah, if we go down to the transferring functions, so we can see that he's using this accounting contract, which is an interface, um, which has these two functions on it. Which on upon first sight, you might think that this is like just a helper contract, but there's really no reason to be using a whole other contract just to complete your transfers. This is always something that's just baked directly into the ERC20 contract, which is this EagleBit contract. There's really no reason to be using an interface, for example, as he's doing here, in order to finish his transfers. And if we go to the transactions, we can see he set his accounting address here. So we can go here um, and decode the input data, and we can see that this is his address for his accounting contract. And if we go to that contract on BSC scan, it's not even verified. So this is another example of very untrustworthy behavior. You know, the use of this accounting contract is extremely fishy, and this is definitely uh, where the scam lies. So a lot of people who are doing these types of scams, in order to maximize their money, they actually also use what's called a honeypot scam, and that's basically a token that you're not allowed to sell. Um, and this is probably the part, like this code here in this accounting contract that we were able to narrow down. This is the this is the part that is doing the honeypot. And another interesting thing to see actually is this this random unverified accounting contract that this guy is using in all of his tokens has been published almost 12,000 times. So it's probably the same person or the same group of people who's using the same exact contract over and over and over again all day just with an automated program. And yeah, I mean, it seems to work for them. They have a lot of liquidity to move around, and they've been doing it for a long time, and they continue to do it. So there must be some profit that they are making. Um, but yeah, it's a pretty interesting analysis of this. That is pretty much the basis of everything that we did in our paper. Yeah, yeah, I appreciate everybody for watching this. Um, Jack, Conrad, and I put a good amount of effort into this, and yeah, so this was the methods demonstration for investigating fraudulent on-chain activity.